Hello, welcome to this video. Today we're going to do this problem. So we need to find all natural numbers n such that 2 to the n plus 12 to the n plus 2011 to the n is a perfect square. So first of all, you might ask the question, do the natural numbers include 0? And it doesn't matter in this case because if you plug in n equals 0, you get 1 plus 1 plus 1, which is 3, which is not a perfect square. So even if it was included in the naturals, it's not part of the group that makes this a square. So we'll just ignore it. So basically n is bigger than or equal to 1. So now, what do we know about perfect squares? So first of all, in questions like these, usually the good thing to do when asked about when is something a perfect square, a lot of times it's going to be looking at this expression modulo numbers whose square mod that number is limited to like 0 or 1 usually. So something like, so a square mod 4 has to be 0 or 1, can be 2 mod 4 or 3 mod 4. Also mod 3 can only be 0 or 1, can be 2 mod 3, any square number. And it's not that difficult to prove. You just basically check all the cases for some number m modulo say 3, and then square them and see that it only gets 0 or 1. And same thing with 4. So let's do this. First of all, let's look at this mod 3. So we get from 2 to the n, negative 1 to the n. From 12 to the n, we get 0. From 2011, let's see. 2010, so 2010 is divisible by 3, right? So some of its digits is 3. So this is 1 more than a multiple of 3, so this is 1 mod 3, so this will be 1 to the n. This has to be common to 0 or 1 mod 3. So first of all, 1 to the n, that's just 1. And we'll move it to the other side to get the negative 1 to the n. It's congruent to negative 1 or 0 mod 3. But now negative 1 to the n can't be 0 mod 3, right? It's either negative 1 or 1, meaning that it has to be negative 1 mod 3, which means that n is odd. Right, so I can write n as, say, 2a plus 1. So we get 2 to the 2a plus 1 plus 12 to the 2a plus 1, 2011 to the 2a plus 1. Now I'm going to look at this mod 4. So mod 4, this will be 0. This thing, it's 2 to the 2a plus 1, so that's 4 to the a times 2, right, into 4 to the a, and into 4 to the a will be either 1 mod 4 if a is 0, and 0 mod 4 if a is bigger than or equal to 1, right? So the powers of 4, because the powers of 4 are like 1, 4, 16, so on. So all of these obviously are divisible by 4, so there's 0 mod 4, but this will be 1 mod 4. In times 2, because it's 2 to the 2a plus 1, this will be 2 if a is equal to 0, and 0 else. Right, and now 2011, 2012 is a multiple of 4, that's easy to see. So this is 1 less than that, which means this is negative 1 mod 4. This is negative 1 to the 2a plus 1, which makes it negative 1. So this is, So we have this minus 1 mod 4. And because this is a square, this has to be either 0 or 1. Right? But if this was 0, if a was bigger, if a was at least 1, this would be 0. 0 minus 1, that would be negative 1 mod 4. It's not 0 or 1. Which means that it wouldn't be a square. Which means that we need to have the case that a is equal to 0. And we'll just see that it works. If a is equal to 0, this will be 2 mod 4 minus 1. That is 1 mod 4, which is possible. Meaning that we got that a is equal to 0, which means that n had to be 1. Now let's just check if it's a perfect square or not. We plug in n is equal to 1. Anything to the power of 1 is itself. So we get 2 plus 12 plus 2011, which is 2025. And this is 45 squared. And we've shown that for any other value of n, this cannot be a perfect square, meaning that our final solution is only for n is equal to 1. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.